Understanding Bitcoin mining and proof of work. Welcome back to our Bitcoin series. In this third episode, we will be unraveling the mystery behind proof of work, POW, and Bitcoin mining, two key concepts that make Bitcoin secure and keep the network functioning smoothly. If you've ever wondered how Bitcoin transactions are verified or how new Bitcoins are created, this is the video for you. We'll explore what proof of work is, how miners compete to find new blocks, and how rewards and halving shape Bitcoin's supply and value. Proof of work, POW, is a consensus mechanism that ensures all nodes in the Bitcoin network agree on the current state of the blockchain. Essentially, it is a system that requires participants, miners, to perform complex computations to validate transactions and add new blocks to the blockchain. This process is energy-intensive, which makes it very difficult for anyone to tamper with the blockchain's history or add fraudulent transactions. The concept of proof of work wasn't invented specifically for Bitcoin. It was originally developed to combat spam emails and denial-of-service attacks. However, Satoshi Nakamoto adapted this idea to secure the Bitcoin network, ensuring that only legitimate transactions are recorded on the blockchain. Miners are crucial to the Bitcoin network, as they are responsible for verifying transactions and adding them to the blockchain. Think of miners as accountants competing to update the same ledger. Whoever finishes first gets the reward. The reward for adding a new block to the blockchain is currently 6.25 Bitcoins as of the latest halving, and this is how new Bitcoins enter circulation. To add a new block, miners must solve a complex cryptographic puzzle. This puzzle requires miners to find a number, called a nonce, that, when combined with the data in the block and passed through a cryptographic hash function, produces a result that meets a specific condition. The first miner to solve the puzzle gets to add the new block to the blockchain and receive the reward. The mining process is highly competitive, as thousands of miners around the world are all trying to solve the same puzzle. The more computational power a miner has, the greater their chances of solving the puzzle first. This has led to the rise of mining farms and mining pools, where miners combine their resources to improve their chances of earning rewards. The difficulty of mining is automatically adjusted every 2016 blocks, approximately every 2 weeks, to ensure that new blocks are added roughly every 10 minutes. If miners are solving puzzles too quickly, the difficulty increases, and if they're solving puzzles too slowly, the difficulty decreases. This self-regulating mechanism ensures that Bitcoin's block production remains stable over time. The difficulty adjustment is a key factor in maintaining the security of the network. Since proof of work requires significant computational power, any malicious actor attempting to alter the blockchain would need to control over 50% of the network's computing power, an extremely costly and impractical endeavor. This makes the Bitcoin network highly secure against attacks. One of the most important aspects of Bitcoin mining is the concept of halving. Approximately every 4 years, the reward for mining a new block is cut in half. When Bitcoin first launched, miners received 50 Bitcoins per block. In 2012, the reward dropped to 25 Bitcoins, then to 12.5 Bitcoins in 2016, and to 6.25 Bitcoins in 2020. The next halving is expected to occur in 2024, reducing the reward to 3.125 Bitcoins per block. Halving is an essential part of Bitcoin's economic model, designed to introduce scarcity. By reducing the rate at which new Bitcoins are created, halving helps control the supply and maintain the deflationary nature of Bitcoin, similar to how gold becomes harder to extract over time. This scarcity is one of the key factors driving Bitcoin's value, as there will only ever be 21 million Bitcoins in existence. One of the major criticisms of proof of work and Bitcoin mining is its energy consumption. Mining requires a significant amount of electricity, as miners use powerful hardware to solve the cryptographic puzzles. Critics argue that this energy use is unsustainable and contributes to environmental problems, especially when powered by non-renewable energy sources. However, many proponents of Bitcoin argue that mining can be a driver for innovation in the energy sector. For example, miners often seek out cheap, surplus energy, which has led to an increase in the use of renewable energy sources like hydro, wind, and solar power. Some mining operations are also repurposing excess natural gas that would otherwise be flared, turning a waste product into something productive. As mining has become more competitive, mining pools have emerged as a popular way for individuals to participate in the Bitcoin network. A mining pool is a group of miners who combine their computational power to solve blocks more efficiently and share the rewards among participants based on their contribution. This makes it easier for smaller miners to have a consistent income, rather than relying on the rare event of finding a block on their own. While mining pools have made it easier for individuals to participate, they have also raised centralization concerns. If a mining pool grows too large, it could potentially control a significant portion of the network's hash rate, posing a threat to the decentralized nature of Bitcoin. This is why the community closely monitors the distribution of mining power. Proof of work is just one of many consensus mechanisms used in blockchain technology. Another popular mechanism is proof of stake, POS, which is used by other cryptocurrencies like Ethereum 2.0. Proof of stake relies on validators who lock up, stake, their coins as collateral, rather than using computational power to validate transactions. Bitcoin's proof of work remains the most battle-tested and secure consensus mechanism in the blockchain space, making it a key part of why Bitcoin is trusted by millions of people worldwide. Bitcoin mining and proof of work are foundational to how Bitcoin operates. By requiring miners to solve complex puzzles, proof of work ensures that the Bitcoin network is secure, decentralized, and resistant to attacks. While mining can be energy-intensive, it plays a crucial role in keeping Bitcoin's blockchain reliable and in line with its fixed supply model. In the next episode, we'll be exploring Bitcoin wallets and addresses, how they work, the different types available, and how you can keep your Bitcoin safe. If you found this video helpful, make sure to like, subscribe, and click the notification bell so you don't miss the next episode in our Bitcoin series. Thanks for watching, and see you next time. Don't forget to subscribe for the latest updates.